Welcome to today's video, where we're going to tackle a fascinating topic in the realm of signal processing, NRZI, signal decoding implementation in Python. If you're working on projects involving data transmission or storage, you might have come across this concept before. But even if you haven't, don't worry. We'll break it down from scratch. NRZI stands for non-return to zero, inverted of encoding binary data onto a physical signal. It's widely used in various fields, including telecommunications and digital storage systems. However, implementing NRZI signal decoding can be tricky, especially when it comes to Python programming. So, what seems to be the issue with the current implementation? Let's dive into the details. To understand where things go wrong, we first need to grasp how NRZI encoding works. Essentially, it involves converting binary digits, zeros and ones, into a signal that can be transmitted over a medium, such as a wire or through the air. The non-return to zero part refers to the fact that the signal doesn't return to 0 volts between each bit. Instead, it switches between two different voltage levels. Now, when we decode this NRZI encoded signal back into binary data, we need to detect these transitions accurately. Here's where things can get complicated. Python, as a high-level language, abstracts away many low-level details that are crucial for precise signal processing. This abstraction can lead to inaccuracies or inefficiencies in the decoding process. A common pitfall is incorrect handling of edge cases. For instance, what happens when the signal is noisy or distorted? A robust implementation should account for such scenarios and provide a clear method for dealing with them. Another issue might be the choice of algorithm. Some approaches are better suited for specific types of signals or transmission channels. To give you a clearer understanding, let's consider an analogy. Think of NRZI decoding like trying to read a book with a flashlight in a dark room. If the light is too dim, weak signal, or if there are too many shadows, noise, you'll struggle to make out the word. Similarly, your Python implementation needs to be able to illuminate the signal correctly and filter out any shadows that might obscure the data. Before we wrap up, let's summarize the essential points. 1. NRZI encoding is a method of converting binary data into a physical signal for transmission or storage. 2. Decoding the signal back into binary data requires accurate detection of transitions between voltage levels. 3. Python's abstraction can lead to inaccuracies in signal processing if not handled carefully. 4. Edge cases, such as noisy signals, need to be accounted for in the implementation. That's a detailed look at what might go wrong with NRZI signal decoding implementation in Python. Remember, understanding these concepts is crucial for working with data transmission and storage systems. If you have any questions or would like further clarification on any of the points discussed, please leave them in the comments below. Don't forget to like this video if it helped you grasp the topic better, and consider subscribing to our channel for more content on programming and signal processing. We'll see you in the next video.